All right, this video is going to cover 1.4, which is inverse of functions. I'm going to start with a function cannot repeat x values. Can't repeat x values. So here's what I mean by this. If you had a graph, and imagine here at 2, you had multiple dots, or the line went like this or something. That means it's not a function. It has to be able to pass the vertical line test. So that's where I would start with that. And then I'm not really going to answer these right now. Let's just look at the example 1. So they give us 2 lines, G and F, and they want us to plot these coordinates. So we're looking at F first, which is the blue one. And we'll fill in these coordinates. So -7, -3, that's right here. I'm just picking random coordinates from this line. So -1, 0 would be right here. And then you've got 1, 1, you've got 3, 2, and you've got 5, 3. So now they want us to pick some points from g of x, which is the red line. That's this one right here. So same thing, -3. Looks like -7, it's right there. 0, -1, 1, 1, 2, 3, and 3, 5. I'm just choosing random coordinates on this red line. Okay, now they want to know the domain of F. I'm right here. So this line has arrows on both sides, meaning it goes left forever and right forever. That means the domain is all reals, or everything from -infinity to +infinity. They want to know the range of G, which is this red line. Well, it also has arrows on both ends, so it's going to go down forever, up forever. So the range is all reals here. The range of F, it goes down forever, up forever. So it's all reals. And the domain of G, it goes left forever, right forever, so all reals. Okay. Do the lines reflect over the line y equals x? Okay, this is the most important thing so far. Basically, for a line to have its inverse perfectly, it has to reflect across this green line right here. This is y equals x. It's right there, you can see it better. So basically, like, these points have to be perfect reflections across that line. So this one does. Okay, now they want us to do some coordinates. So they give us f of x as a list of these coordinates. So -6, 0. -2, 2. 0, 3, 4, 5, and 6, 6. All right, so blue looks something like this. This is f of x. All right, now what they're telling us to do is write the ordered pairs for g of x by switching the x and y values. So we're going to take this and switch these values. So like 0, -6 would be my first one. Literally just flip-flop those. Okay. And now they're going to want us to graph this. So 0, -6, 2, -2, 3, 0, 5, 4, and 6, 6. So g of x, the red line, looks something like this. Okay, and so you'll see that, again, just by flipping those xy coordinates, it reflects them across this line right here, this green line, y equals x. So let's keep moving. Now they want us to graph f of x, which is this right here, 3x plus 6. So start at your y-intercept of 6, rise 3, run 1, and then go the other way. Okay. So function f is blue there. Now they want function g by getting the inverse of this. And to get the inverse of this, first you take this equation and you switch xy. So it looks like that. All I did was switch these letters. Now you have to solve for y equals. So you're going to minus 6. And then you're going to divide by 3. So you're going to end up with y prime. This right here, both of these things get, I'm talking about this right here, both of these things get divided by 3. So it's like 1x over 3, and then minus 6 over 3, which is minus 2. So the equation's 1/3 x minus 2. So start at your y-intercept, rise 1, run 3. It's going to look something like this. Okay, I can do better than that. Something like this. Okay, and then they're telling you to identify some following points. So f of -1, this is an input. So you find your -1 on your input, on your x. So that would be here. And then you find where it is on the line. So at -1, I'm at this point right there, 3. G of 3, so now I'm on the red line. I'm finding where 3 is on my x and finding what the output is. That would be -1. So that's all they want you to do there. Okay, and then these last two. Does this line pass the vertical line test? Yes, it does. It does not hit twice anywhere on there. So sketch a graph that reflects over the line y equals x. All right, so you can just pick some coordinates of this. And so like this is a coordinate, -4, 4. Here's another one, -2, 1. We've got 0, 0. We've got 2, 1. And 4, 4. That should be enough coordinates. All right, so when you go get the inverse of this by flipping xy, here's what you're going to get. 4, -4, 1, -2, 0, 0, 1, +2, and 4, 4. Now you can plot these. So 4, -4 is here, 1, -2, 0, 0, 1, +2, and 4, 4. So when you connect the dots, it's going to look something like this. It's like a parabola turned sideways. And they want to know if it passes the vertical line test. Well, the answer is no, because it's hitting twice now. So that's what they wanted to kind of show you there. Okay. Now, inverses algebraically. Basically, I don't know why there's 3 steps. There's really only 2. You're going to switch xy. And then you're going to solve for y equals. It's really y prime, but. Okay. So this right here says y equals 2x minus 3. The first thing you do is you switch xy. So now it's x equals 2y minus 2, not 3, 2, sorry. Now you need to go solve for y equals. So you're going to need to add 2. Divide by 2. And again, both of these things get divided by 2. So it's like x over 2 plus 2 over 2, which is 1. This would be your inverse. Let's look at another one. Switch xy. So now it's x equals -3y plus 4. Subtract 4. Divide by -3. So it's y prime equals, I have x over -3. So you can just leave it like that. And then -4 over -3. A negative over a negative turns positive, so it's plus 4/3. Okay, this next one, switch x, y. So you got x equals 2/3 y minus 4. Add 4. All right, now to cancel this fraction, you're going to hit it with the reciprocal. So the reciprocal is when you flip this fraction. So it'd be 3/2. You need parentheses on this left side because you're going to have to distribute that. So you do this because the 2 and the 2 cancel and the 3 and the 3 cancel. And it just leaves that y. So I'm distributing 3/2 on the left side. So now it's going to be 3/2 x. And then 4 times 3/2 is 6. So plus 6. Okay, and then the last one's probably the easiest. Switch x, y. Then just subtract 5. So that's how you do inverse of functions graphically and algebraically. Hope this video helped.